So just to break it up into manageable chunks. Okay, so this, I'm embarrassed by this. I must tell you straight up, I'm embarrassed by this. But I was the deputy principal at Inverborough. You can look it up. It's a school in Sydney's Sutherland Shire, and a very expensive school, the most expensive school in the south. So you've got to go to Danebank, or you've got to go to somewhere else. So I had a wonderful time there. But one of the things that I noticed about my maths teaching was that I often felt that I wasn't getting the best out of myself. You know how you sometimes you just think, what's going on here? And they had this policy. They had this policy of get them into general maths. So they'd have like 3 or 4 general maths classes in a year, and there'd be one advanced class and a handful of kids going into extension. And it's a very common feature of many schools. And they hedge their bets by doing this and saying, because it's kind of a bit of a coward's way out in the sense that, oh, well, if you didn't do well in general, it's not our fault, you know. But if they don't do well in advance, that's our fault, you know. But I'd rather have that struggle with them because what comes next. So I had that kind of culture in culture. Now I was teaching 3 and 4 unit maths. I had a mentor, and he was awesome. He was such a he'd been doing it for. I said to him one day, just out of sheer frustration, "How did you know how to do that?" He said, "Come on, Jason. I've been doing this for 30 years." So there's something about experience too, you know, and it's not just raw intelligence. So that was nice of him to acknowledge that. And but still, we had this culture of get them out and put them into something that they're more akin to. Now, I came along and I said to the Year 12 group one particular time, I think I've told you this, who wants to do extension 2? Meet me here at lunchtime. And I got in a bit of, you know, because they'd only ever had one student do 3 unit or 2 unit, 2 or 3 students doing extension 1, one student doing extension 2. So for me to come along and do that was either being a cowboy or an idiot or unaware or whatever it was. And in the culture of the school, you know, there's some merit in what they were saying, because the risk was they really hadn't been prepared for advanced to a high level, you know. So I went to my own school. I got a job as a principal, and this school I went into was an accelerated school. I remember meeting this young lady. I don't know what it is, but I met this young lady, and I thought, oh yeah, you'll be doing general maths. And she told me she was doing extension 1, and I fear that I embarrassed myself with a look on my face, as if a look of disbelief. Like, here I'm being prejudicial, misogynistic, whatever you want to call me. Shoot me, take me out on the wall and shoot me, because I think I did. I just embarrassed myself. I was so inculcated with this whole mechanism you just described, Trisha, of let's not, you know, let's not grab the tiger's tail, and it made me realise that I'd been having a mistake. And you've got to have a bit of faith in kids, and this is why it comes down to training. Because I came through school like everybody else, and we always got told by everyone it's all about the super intelligent, and it's not. It's not about that at all. And I think Australia makes a big mistake with this. I think they still lead on this a little bit, and I feel as though there needs to be a change to the way we approach what you do advanced maths for. And I think you're right. I think it's careers and it's progression and all of that stuff. And in the US, for example, they get told, have a go. You know, you can do this, get into it, make it work. So it's not to say that we're going to make promises and get students who aren't suited to do it, but gee, there's a lot of students who are missing out. You know, they're just missing out because there's not an adult teacher who's willing to take a risk. So after that experience and after a bit of reflection, I just decided, no, I'll give them a fair go. If they want to have a go at it, 90% of it for me is if they turn up at the door, and that's not policy in any school for advanced maths, they can have a go, right? Because if they really don't get the training and they can't manage it, it'll come out pretty quickly, and they'll make a change. But if they hang in there and just keep walking with it, you'd be surprised the people that can get results that surprise you and shock you. And you know, doing an engineering degree in a university is not that hard. It's not. I wouldn't say that about a maths degree because that's a challenge, right? But it's just not. So kids are missing out, and they shouldn't be missing out. And yeah, so just all power to you, girl. If you go and encourage some kid, and then you feel bad because you feel as though you're lying to them, that's not a lie. Okay, if they want to do it, they're going to do it after you and your school. Wherever they go, they're going to get the help they need at university somehow, some way. Now, it might not happen in the next year, but it might happen in the next decade. Do you know what I mean? It's kind of that life journey. So, yeah, tell it.
Yeah, and I feel really strongly about it because I was one of those students. I myself, I did advanced and I could have done extension, but I remember the maths teacher I had, I was in the top year 10 class. She was like, no, she didn't want to take the risk on me. She was like, she just wanted the top, she wanted the top, two students or whatever. So she was like, no, and I still remember. So after that, like every student now, I'm like, no, you can go, you can do it, you can give it a go. So like and even some of them, like there's some that are really able in my class
Yeah,
and they're not doing it, and I'm just like, why? Like everyone, you should be doing it. And it's so hard because it's this culture, and I think I was affected by it too, because I actually thought I would have gained a lot,
yeah,
doing it. I think I would have really
absolutely.
loved
Yeah,
it, and I didn't get that chance, like,
yeah,
so
yeah.
it's annoying.
Well, let's do a thing. I'm happy to, let's do a Saturday school where we do a few hours each for a few Saturdays just to get people, different stage levels and stuff excited. One of the things that I think is that there's nothing wrong with telling a student to have a go. There's a difference between saying oh you can do it as opposed to have a go. So the other thing is the mindset of the phrasing. We've got to get away from calling top students. You want the top students? No, you don't. You want the students you don't have to teach because it's work. This is work, right? Well, you see what I do with you guys, and that's not negative. It's training. It's what I'm paid to do. So do your job and train. Not you guys, but these people that are saying I only want the top kids. Do your job and train them. That's the job, right? Give them the skills that they need to do the work that's going to be presented to them. It's not hard. Well, it is, but that's the job, right? If we can do that, then we're going to have kids all over the place winning. So anyway, mindset change of language. Top students know students you don't have to teach. That's all you want. You want students you don't have to teach. No, not good enough.
And I'm trying to like sell UTS to some of them. Like, if you do engineering, you should go to UTS. So
Yeah,
like, it's
why
a really
not?
great. So I'm
Yeah.
like, you might as well. I'm like, I go there. It's really good. So
You know what? I was I'd had my principalship. I was working at university, and one of my daughters, actually both of my daughters, went through this school, and one of the daughters wanted to do advanced, and the fights that I had to have with the head teacher to get her in, and you know what she did? She singled these three girls out. It was three girls, I think, and put them into like special classes, before school type classes, and she just caned them. And she didn't train them. She didn't train them. She caned them. And my daughter's ATAR was good enough, so she ended up doing general maths. And I was it's like a bargain. How much of a fight are you prepared to have, and what price are you going to pay? I mean, I already paid the price because you know me. I'm not backwards. I made myself unpopular with them just by speaking out. But they were determined. This particular head teacher was determined that she knew everything. She was the oracle of that particular system, and it's not the case. She was a fraud as far as I'm concerned. But the kid just needed the training. Now I'd spent a lot of time helping her, but now that particular daughter needed the help. Okay, but that's the job, right? It's to help them. So, and the ATAR that she got would have got her into engineering. Did she choose it? No, she wasn't going to choose it. So the frustrations are real. I hear you. All right, so what we've got to do here is an equivalent. We're going to DDX an equivalent, and this is very counterintuitive, isn't it? So we're going to put it as all of a sudden we're bringing up these parts. Or no, x ln of 7. X the ln of 7. That's how we're going to actually go ahead and complete it. Alright, it's very, very confronting. So in this case we're just going to be left with the constant. We've got, and so that's going to be e to the And so we're going to end up with ln 7 e to the u. And the change of form is the thing that's very striking. That's the part that's difficult. And if you wanted to, recognizing that that is in fact 7x. So very, very confronting. Alright, how are we going for time? Alright, so we're all good. Can we do this one? So hopefully that's been somewhat edifying. Let's go back into this one now. Oh no, I've missed one. All the second partial derivatives. Sorry, I just skipped ahead there. 3. Okay, so for 3 we've got our function. So our first derivatives will be with respect to x, so we'll get 2x plus, and then the x will disappear but the constants remain. That constant's gone because the derivative constant's 0. Very contradictory, isn't it? The partial with respect to y, okay, is that's a constant, so now it's gone. So we get 2y plus 3x. So that's that part. Alright, the next thing we want to do is we want to take a d dx of x squared. So we're going to do our partial with respect to x of the function x. Actually, I want to express that in a simple way. That's going to be confusing. Okay, so we're just going to take d dx of f of x. So we're going to do our partial on 2x plus 3y. So this is the derivative. So with respect to x, the y terms disappear and we're left with 2. The yy is with respect to y for f of y. So we're going a partial with respect to y of 2y plus 3x. So with respect to y, the x term disappears, so we're left with 2 again. Okay, now the next one is a bit tricky. The next one is f of x, y, and f of y, x. So what we do is we go to the y first derivative, and then we take x. So the y first derivative is this one. So for this one we're going to take the partial with respect to x of the y. 2y plus 3. And for this one we're going to go to the x and take the y. So we're taking the partial with respect to y of the x, which was 2x plus 3y. So it's counterintuitive again, they all are. So the d dx of this, the y's are constant, so they're gone. So the partial with respect to x is just going to give you 3. Same again here, the partial with respect to y, the x is gone, so we're just left with 3. And so they're the same. And you'll find that this is the case. Okay, so when we come to do determinants using those, it's, yeah. Alright, so how do we go with that? Okay, any questions? Alright, so we can do 4 now? Yep. Look, right, dfdt for the function. This is a bit tricky because it's find dfdt, which is like what? Okay, and I should fix that up. That's square root of d. Okay, so we need to do the differentials. This is a chain rule tree type function because it's with respect to t. So we need to do a couple of things. We need to do the partials with respect to x. So with respect to x, the cos y term is a constant, so it will remain, and the differential of sine is cos, so we're going to get cos x cos y. Very counterintuitive, isn't it? With respect to y, the y term is the one we're going to operate on. The x term is a constant. As a product, it's going to stay. It's not by itself. So we're going to have sine x, and the differential of sine is cos, so the differential of cos is minus sine. So this will be minus sine x sine y. Okay. What else have we got? This one here, so we need dx dt. So that's just pi. And the y dt. Now that's annoying because it's t to the half pre-work. So we're going to get a half t to the half minus 1. Just doing the gymnastics because if you just do the obvious, oh, half minus 1's minus a half. Okay, fair enough. So our df dt our partials with respect to x, and then our increments in x, and our partials with respect to y, and then our increments in, sorry, that should be a t. That should be a t. No, what did I do? I panicked, I saw the wrong thing. All's well. Okay, so that's good. And then so all we do is take all of these bits 1, 2, 3, 4, and we sub them in. So we get cos x cos y times pi, and then we'll get a minus a half square root of t sine x sine y. So that's just putting those two together. Now we also have some values for x and y, so they can now be substituted in. So cos x is cos pi t, cos y is cos the square root of t. So this is the change of coordinate system, and we'll put pi out the front, so it's a convention. We've got the half square root of t sine pi t, so we've got everything in terms of the new coordinate system. And then we can go ahead, so that's basically an answer, one answer, but we need to do it when x okay, so did it say t equals 1 specifically in the question? It didn't say that. I don't know if I've left that off or if I'm just doing that. When t equals 1, we'll get, I might be just showing now sine pi by exact values trig is the height of that one, which is 0, so that's a 0, so all of that second term is gone because that's a product, so we're just left with this one. Cos pi at that point is -1, so it's going to be -1 times pi, so it'll be negative pi cos 1. So change of coordinate system just simplifies the calculations, but in order to change the coordinate system and invoke these cylindrical polar other systems, you need to know exact values trig well. Okay, that's the part. Alright, use a tree diagram to write out the chain rule. Oh, so it doesn't actually want anything too dramatic. Okay, so we're going to start off with our function. We'll start off with our partials. We'll go down the x. Well, it's RST, isn't it? So it's x R S T Y. Okay, so we'll come through the partial with respect to x, dr, ds, dt, so I'll just do one. The partial with respect to r, and so you repeat that for the others. For this one here, it's the partial with respect to y, and then for each of these it'll be the partial with respect to y, so that's the chain coming together, t, and you do the same for each of these. So if we go down and do that, and f was of u, wasn't it? So the partial and the partial. do we just follow the tree? So we've got the first branch, then the other branch, done. For this one we're going to go through f of x again, but this time we're going through s. And yeah, so then you do that. So if there's a question related to that, that's a lot of work to get those out, but I don't think I ever did that. I think I've got a fairly simple one here for ST, and this is the change of dimension.
Can I just check? Did you write something wrong the first line? Whether it's like
Fy
oh,
y r.
is that
That's an
okay?
R. Sorry. I've often been criticised for my writing. You should have seen me at school. God, it was terrible. You know what I hated going into these classrooms and the teacher would just, it's like so a work of art, you know. It used to drive me up the wall. I didn't get that gift. Alright, so we'll do the last one. I think we're going okay. Can I take that away? Because I'll post these as well. Alright, so moving around the coordinate systems for an engineer and a scientist is a big deal. Okay, but once you get the hang of these things, this is what kids need to learn, right? The world, it's open to you. You know, I said to both of you, if you get sick of doing teaching, you can go and be a scientist or an engineer. What's to stop you? Absolutely nothing. You're going to be doing more of this, that's all it is. So if you like this, that's it. Alright, so we're going to build up r and theta, and we've got r in terms of st and theta in terms of st. So we'll have our function, please, in terms of s, and our function in terms of t. So they're the goals. So we've got the partial with respect to r, and then we've got r s plus theta. That's the one we're looking for. So we've got to do them. So our partial with respect to r, e to the r is just e to the r. So it's going to remain e to the r cos theta. That we love it, honestly. And the constant will remain. With respect to theta, e to the, or with respect to theta, e to the r will remain, and the differential cos is minus sine. So that's those two done. Then over here we've got the ds, which will be t, and the I'll do it for later. dt is s. You would have to be annoying, wouldn't you? d theta ds. So it's going to be okay. So it's going to be 2s and 2t on top of those. So for the s, it's going to be and for the theta dt. So this will be e to the r cos theta times t plus minus e to the r sine theta times s over yes. Alright, now we've got to make our substitutions. Oops. So we've got substitutions for r and theta. I think I've got to put the t out there too, haven't I? Then I've got so they're actually easier. They're easier in those forms than they are if you stayed in the Cartesian system. They're actually easier, believe it or not. So, alright, we've got to go through the r's now, through the t's, the r's and the t's. And the thetas. PT. Okay. So we've got df dr. Which one's that one? dr cos theta again. Dr dt this time was s. So we'll do the plus is going to become a minus by virtue of that one there. I'll have to add this sheet into that sheet tonight because I've written on it a fair bit. Okay, so then we've just got to make some subs. So we've got S, E to the ST, cos. That's it, I think. Okay, so you can see that there is a rigmarole to go through, but it's the thing, you know. Your work is your maths. Your work is your maths. So these are not that bad once you get the hang of them and get a bit of time with them. But again, all of that's about the practicality of doing maths for a living at this level, or in an engineering career, or in a scientific career where you've got the time. And none of that is to take away from the version of the maths that you're doing in your career and the way that you're working. Okay, so don't feel that when I make those statements, they're not glib or intended to be detracting in any way. They're just, if that's the door that you want to walk through in the future and spend time doing this kind of maths, that's a future door. Why not? It might be something that you'd be interested in. There's no harm in asking if the you know, School of Education needs a tutor or two, or you could do tutoring in the science faculty as well after you've got your masters. Yeah, so that's pretty much that out of the way. Alright, so did you have any questions related to any of the schoolwork type questions that are coming up?
So that last question there and the trick, they're on Canvas, aren't they? Similar. I know the Canvas content for this week's quite a lot, so
Yeah.
Okay,
Yeah,
cool.
So I think for the both fortnight, you know, look, I'm always very careful about how I unpack this, and there's no exam, so you've got enough to do the other part, I think. We are talking about this, aren't we?
Yeah.
Yeah.
Yeah, just the last two. Yeah, so I've done my vectors homework. I just haven't uploaded it yet, but I will scan it and
It's
upload
all right. It's all right. You know
Great.
me. It's fine.
Yeah.
I'm not going to pressure people that are teaching in high school. It's just not going to happen. All right. Oh well, I think we've done well. Maybe we'll give ourselves an early mark. What do you think? If you're not going to hit me with a 4-unit or a 3-unit question that you're mulling over, or a technique or something, because you can if you want to look at something. Other than that, we'll call it a night. Thanks for coming, and I'll see you next week.
Great. Thanks, Jason.
All right. Well
Thank
done,
you.
guys. Thank you. Hooroo.